Hey everybody, welcome to IBM Codecast. My name is Spencer Crum. I'm happy to be casting with you today on Twitch. What we're going to do today is we're going to look at a technology called Istio. So Istio kind of came out of, we're going to be looking at Istio and Kubernetes basically. So Istio is a piece of software that came out of Lyft and IBM and Google. But what it sort of does is, broadly speaking, called service meshing. And so we'll talk a little bit about what a service mesh is and what that means, and what it does for you in a hot sec. But first, I want to kind of call out an open source project, which I think is kind of cool. And so that's this thing. This Kragnes fellow or lady has created something called Tor controller, and so the idea is here that you can run the onion in Kubernetes, which is pretty sweet. So he's got a little diagram, which is actually super nice. I'd love to know how this diagram got made. Probably Keynote. It's always Keynote. But yeah, so there you go. This probably uses the controller, the operator pattern, which is pretty cool. This is the kind of thing where you're sending in a custom service, custom resource into Kubernetes, and then it sort of creates its own stuff. So you can see here a custom resource definition, kind onion service, and then you have a very simple API like I need some Tor running, and you send that in, and then the actual controller or operator gets it done. So pretty cool stuff there. Definitely worth checking out. The other thing I want to call out is at OSCON, if you're going to OSCON or you're going to be in Portland for these kind of days, check out the Istio Day, which is Tuesday. And basically there's a whole day dedicated to Istio, sponsored by IBM and Google Cloud, I guess. And it's just going to be a whole day dedicated to Istio. And there's some sessions and there's some hacking. And there's, if you want to get going on Istio, this is a great place to go. If you'd like to start hacking on Istio, this is a great place to go. If you're looking at other stuff, this is probably pretty good. Yeah. There's some basic debugging from Liam. Should be pretty good. So I definitely check out the Istio Day if you have time or you have the options. I don't know if there's going to be like a live stream component of Istio Day. It kind of comes down to what OSCON wants to do. I know that the thing is basically free. So I think they're trying to just, maybe it's not free. Maybe you need an OSCON ticket. I don't know if you can get through it or not. If you want to go to this thing, and it's open to all OSCON pass holders, but here's the thing. It's like, we work at IBM, so just tweet at me if you really want to go to OSCON. If you really want to go to Istio Day, and I could probably get you in, like no problem. Like we want to share the gospel of Istio as much as possible. It's a good word. So that's kind of why we're doing a little presentation on it this morning, which should be fun. And I think this is all done at the it doesn't say, but this is at the open source or the same place they always did OSCON for like 20 years, the Oregon Convention Center. OSCON went to Austin for 2 years for no reason, but now it's back. So that's awesome. And so there's some great stuff you can learn right here at OSCON. So check that out. All right. So what is Istio? We got all this, beautiful diagrams and stuff. I believe that if we come in here, yeah, so let's look at this guy. So, I know mind-bending or mind-blowing, or not mind-blowing, but just like jellify. Like your brain is just jelly already. I haven't even shown you anything. Here's the deal. They're kind of making see here we have service A and service B. What we're saying is we're going to sort of change the way Kubernetes does inter-service communication. And we're going to use Envoy for that. And Envoy is a part of Istio. So Istio sets up everything we see here, plus a bunch of other stuff. And then Envoy is kind of this thing that actually gets there. You know, if you're not too familiar with Envoy, that makes sense. It's relatively new. Lyft wrote it. And what Lyft did is they mapped this kind of vocab word, service mesh, across their entire infrastructure. And there's a great talk from Matt Klein at Lyft on why they did that and what they did it for and how they did it and all this stuff. But Envoy is written in C++. It's like a single binary. Has like configuration files and all this stuff. It's just a daemon. And in a pre-Kubernetes world, Lyft basically had all these envoys deployed basically on every VM that ran interesting services at Lyft. And what they did is they took, you know, you can kind of imagine this pod as a VM, right? Just, it's not, but imagine it was. What they did is they basically said like app name service A, instead of talking directly to other services, just send all your traffic to Envoy, and then we'll put some configuration in Envoy so that Envoy then forwards it where it needs to go. And this is reflexive. So on the other side of this, you know, you'll see service B is talking to Envoy as well. So basically, every time service A wants anything, it goes to Envoy. Envoy on this machine goes to this Envoy. Envoy goes back to service B. And so you're actually making 1, 2, 3 requests instead of just a direct service A to service B request. Now, that is a bit spicy. That's a thing that you can do. You don't have to, but you can, right? Like, okay, why do you do this? Well, the short answer is that it gets you some advantages. And again, let's talk pre-Kubernetes for a hot sec, like the use of Envoy at Lyft, right? What you get from there is sort of a hack around service discovery, right? In Kubernetes, you have a pretty well-functioning service discovery system, but outside of Kubernetes, where you're welcome to deploy Istio, you know, where is the database? Where is the avatar service? Where is the user ID service, right? Like, you're going to have to ask DNS, or you're going to have to ask etcd or something like that. And you're going to have to kind of build that yourself, because what people do, the reality, whether you're in Amazon or you're in IBM Cloud or you're just with a bunch of KVM hosts on your computer or whatever, you know, there is a set of machines probably behind a load balancer that answers for service foo. And you're going to need to move that IP address around, that name address. You know, HA Proxy and Nginx have done some significant amount of work making it possible to like drain providers and add new providers behind a backend and stuff. And Envoy sort of says like, I'm going to handle the whole piece of service discovery and routing connections and sending data, right? And there's a few other things that you get. Most notably, you get this ability to say like, because every request in my entire service mesh is going through the service mesh has unparalleled ability to inspect what's going on, to watch program flow as it traces from computer to computer to computer, to watch you know, where latency spikes come up, you know, administer retries, right? And like the thing that I immediately said when I was kind of told about this is like, okay, well, retries are cool, I guess, you know. Service A needs to talk to service B, it should retry twice and then, or 3 times or something, and then write a log error like, hey, failed, bro. No, I'm done. And then, you know, you want to know what the latency between service A and service B is. We'll just have service A log that, right? Like, okay, yeah, pretty reasonable. Or emit it to some kind of like a statsd endpoint or something, you know, whatever. Put that in the app. You know, I have a lot, as a developer working on service A, I have a lot more control of service A. And so it's in my language. It's what I know. Like there's some really cool, look, the problem is just, I don't have enough time in the sprint to like add all the cool telemetry stuff that I want to service A. It's not that we need to like push all that to the infrastructure layer. Come on now. Like, that's what I said. I said, like, I don't want to do anything. And then I sort of became convinced that this doing it at the infrastructure layer actually gives you some things. Let me tell you what kind of convinced me was this idea that, imagine for a second that you had service A in Python and service B was in PHP. Right. And it's like, it's just been around for a few years. It's called like, it's one of those apps at these infrastructures of these companies that just lives forever. It's called like utilities. Like raise your hand if you've been at a shop that literally had a PHP app called utilities or process or IP management or something crazy. It exists. We really wish it didn't exist, but it does. You don't even have to put the monolith label on it. It's just a big app that like we got to run, and it doesn't provide any value. We're not gonna make any more money if it goes faster, but boy, it sucks to run, right? You're not gonna backport instrument that as part of your like company wide or engineering wide or effort to instrument the app or get telemetry. You're just not gonna go back and do it. But even if you don't have that problem, even if you have Java in Service A and Python in Service B, or Python 2 in Service A and Python 3 in Service B or something, if you have any discrepancy between the exact architecture of these two applications, it's very difficult from like a wider SRE view of the app, of like the whole app, not just individual services, individual microservices, to necessarily trust what's being vomited into StatsD and Graphite or Grafana or InfluxDB or whatever your thing, or SignalFX or Datadog or whatever your vendor is these days. The point is that when you end up trying to write basic telemetry around, what request response time is into Service A for requests it's making, you're going to use some library. And their concept of like, oh, do we record right when we sent the request, or only after the request is in flight, or once it's at the top of the queue? These kind of concepts are going to be different in the library in Service A and Service B. It's just going to be different. So you're going to be comparing slightly oranger apples to other apples. And it's going to really, best case scenario, they're a little off. Worst case scenario, they emit different stats under different names, right? And you're going through and you're screwing around with gauges in one area that is in telemetry, and another gauges that are in different units under different areas. And you're building these very complicated influx charts just trying to get a sense of what's going on. Think about that. But if you do it the other way, where you say Service A has no retry logic built in, it has no exporting of its own telemetry on requests, it has no need to necessarily log requests or transaction IDs or anything. It just sends everything to Envoy. All services talk to Envoy. Envoy does a 3-point turn back to Service B and logs it the whole way with timing information and request retries and all these things. Then all of a sudden you can have one, quote unquote, one pane of glass. And that enables you to see the whole app, where the units are all the same, the metrics are all the same, and actually trace requests through the whole thing. It actually starts to become pretty useful. Now, when we talk about Kubernetes, so at that point, I started to become convinced. Like, look, maybe your organization wants to take a whack at really writing the same the same idea of logging and telemetry and all these things into every major language you perform. Like, let's say you're a shop that uses mostly like JavaScript and Java and Python. Like, okay, make a tools team, give me and you'll come out with 3 libraries called your company-telemetry. Maybe you open source it or whatever, and it has implementations in the 3 languages that your company cares about. Okay, you could do that. Or you could just literally shove it through Envoy. Like, it will be faster and easier. And you can do it kind of like this afternoon, or at least play with it this afternoon, and not wait 2 years for like the results of that work. It's also nicer because there's like, in the spectrum of how hard it is to write stuff, emitting stats to StatsD is not crazy hard. I mean, it's work, but it's not crazy hard. But then like getting your retry logic right, like that is how you bring your whole data center down, because you screwed up your retry logic and you deployed it. There's also some stuff about you deployed it that Matt brings up in his talk, which I'm largely parroting right now. But like, there's this thing where, okay, the tools team or whoever has blessed this one library, and we need to deploy it everywhere. So how do we get every JVM to bounce? Like some teams are less into that than others. And some teams are, on one version of the JVM where they've got a different set of libraries that they've pulled in, and the dependencies are a little weird. And then you need to put a security update in. Like, this is nonsense. If you have a security update in your telemetry and you're trying to iterate in your telemetry, and you're telling the service teams they need to bounce their whole thing the whole time because you're just iterating. Like, shove it through Envoy. Anyways, so that's an idea. Envoy ended up being pretty useful at Lyft. There's this is like a decent one to do. Don't worry too much about this 99% to 1%. We'll talk about that in a second. But it provides some of this cool value. Let's talk about what it means in the context of Kubernetes. Kubernetes doesn't have a problem with service discovery. Service discovery exists like on day one with Kubernetes. We create these things called services and we attach pods to them. And as a result, we're able to get service discovery and load balancing for free. It just comes for free in Kubernetes. So that service discovery and load balancing that you get in Kubernetes, or that you get from Istio and Envoy, isn't the biggest useful thing. Is this going to be useful? Oh, this is going to be sort of useful, less useful, but not terrible. I like this one. So the way this actually works is you sort of have this thing called the pilot, which is part of the many daemons that Istio runs. Like you run in Istio and Istio runs. That's part of the infrastructure, like the I squared. And what it does is it talks to all the different envoys and keeps them in sync. And like for anyone who's worked in this kind of environment, like that's very standard, right? Like there's a bunch of like a fleet of applications whose state is managed by like a central service. Pretty standard stuff. And so what it's constantly doing, and that's sort of how the service discovery is implemented, right? So this envoy knows about all the other envoys by name. And so when we want to talk to service B, it knows how to get that over. And as you can see, it can do kind of like a simple load balancing to all the other envoys, or it can do something cute where it sends 99% to service B and 1% to service B prime, implying some kind of like a staging or an alpha or you're going to do a little bit of a canary deploy type thing there. And you can leave that at 1% and look for failures and then do like a fuller rollout or something like that. So there's a couple things to point out here. One, this basically completely ignores kubedns and the Kubernetes way of making service discovery work. Service discovery is entirely implemented at this Envoy layer, so we don't really need it anymore. And then like probably the bigger question for people who are familiar with like kubeproxy, like the way that in Kubernetes, talking specifically about this pod and this pod and these two pods, the way kubeproxy actually works is on this pod, there's a bunch of IP tables rules that say like where to send traffic for service B. And so the request will be at layer 7 and it'll be routed over layer 4 transparently, 3.4 to this thing. And then at layer 7, it'll contact service B and then it'll come back. And so there's like a direct connection here between these green blobs done through Kubernetes. We're not going to use that. Now what actually ends up happening is that the Envoy little container is what it is, will handle all communications directly to other envoys. And it does it by like, this is a layer 7 like HTTP request, and this is a unique HTTP request, and this is a unique HTTP request. So you're actually sending 3 HTTP requests instead of just 1. And there's some overhead there, but it's not, if that's the performance problem you're at, like, cool. Like, I wish I was you. So that's sort of kind of how that works. The other thing that you might be noticing is there's this pod wrapped around these 2 boxes, and that's because we're doing what's called sidecar injection, which means that we're actually breaking that kind of rule you might have heard in your first Kubernetes training, which is that, one pod is kind of one container. Well, you can actually shove 2 containers into a pod. So there's like service A, which is, later we'll see the guestbook app. And the guestbook app is running along happily. And then in another container, you'll actually have Envoy there ready to go. So it'll just be there and chilling, which should be pretty good. And that Envoy actually has this kind of hacky thing where it's basically just, so when you create service A pod, you actually do something called injection. and you sidecar inject, and then you make another sidecar container right here inside this pod, and that runs the Envoy process. And then when they're co-located like that, the Envoy container actually hijacks all of the network traffic that Service A is trying to do and sends it on its way. So it's actually a very transparent way to use Envoy. Istio, using Istio proxy is what this actually ends up getting called. Service A is very transparent. You don't have to make any code changes. You can literally just shove it in, and boom, all the traffic is going through the Istio mesh. It's kind of what its vocab word called. And you're getting all this cool telemetry about the information. And we'll show that in a little bit. The way the sidecar network interception works is a little mysterious to me, but the best documents I've seen on it so far are that there's basically two IP tables rules. That one says like all traffic that's outbound for service A redirect to port localhost something, 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 which is stored as environment variable. It's called Istio proxy port. And then Envoy picks all those up and reads a sock opt called SO original destination, which is kind of generally used in NAT, but can be used in this. And then figures out where it was originally bound for, sends it on its way. And again, because you have this like greater control with how the envoys talk to each other, you could build these interesting workflows that you otherwise wouldn't have been able to build just trivially with the existing Kubernetes service pod kind of architecture. All right, so that's like enough kind of yakking about Istio. I think maybe we'll look at Pilot for a hot sec. Yeah, this basically covers, ignore Mesos Cloud Foundry for a second. Users tell the Istio what to do, and then the Pilot actually is kind of the manager that sends all these different both service discovery information and rules for how to behave down to all the envoys. So you're going to run one envoy process per kind of application process in your cluster. And we'll see all that in like a hot sec. For those of you following along at home, we're going to use this guestbook dash or some combination of guestbooks, which is just a simple guestbook application. And hopefully we'll be able to show it to you pretty soon. And if you're in New York, I'll be giving like anyways, I don't know about much, but I'll be giving a similar version of this presentation tomorrow afternoon in Spring Studios as part of Datadogs conference. Oh, which I guess we should hype. This thing is a conference that's happening in New York. And so if you're into this, check it out. It says waitlist, but just hit me up on Twitter and I'll see if I can get you in at least for our Istio workshop. Cool. Wow, that is just like a brutal URL. There we go. It's a little bit better. Okay. Boom. So the first thing we're going to do is just like the basics. Let's like make sure that we'll like, verify IBM Cloud if you prefer. Like if you didn't know, IBM has a cloud, and in that cloud you can create Kubernetes clusters. And this and there's kind of some like generic communication you can do with the IBM Cloud Utility, which is called BlueBX. You come in here, and then now we're kind of off the races. We can get nodes or whatever. You can see it's running 1.9. 1.9 is the default. If we wanted to, we could provision a 1.10 cluster, or we could type some upgrade command, which will upgrade this, but we don't really have to. This is all done on like the super free tier, so you only get one VM, but it's got, I think, like 4 gigs of RAM, or it's got enough that we're gonna be able to play like an app to it. And again, like, if you have a credit card or something, you can obviously go higher. But I try to stay, I go back and forth in my advocacy work. Like sometimes I only want to show things to like that are like paid because that's the experience that like a paying customer is going to have. But sometimes I want to stay within the like free tier because that's like the first touch someone's going to get with the product. So I don't know, #DevRel problems. All right, so we've got ourselves, I think that this, you could tell when I named it Herp Derp that like I was really out of interesting names. All right, so we got ourselves a little cluster. Things seem to be going pretty well. So we can, we can really see that A, there's really nothing running that's not in kubesystem, and then B, there's a bunch of random crap running in kubesystem, which if you're familiar with Kubernetes is pretty much standard. We use Calico for networking on the back end, and then there's just some random stuff. This VPN, I think, is only used for the kube dashboard, but don't quote me on that. All right. So then we're gonna start cloning stuff. Cloniones. Okay, cool. And then the first thing I really want to do is just get Istio kind of installed. So because it's 2018 and everything is sad, we get to do something cute like this. My favorite. I think this is actually not the most upsetting thing though, because it's basically just this shell script doesn't really do anything. It's like download some files. Really? Oh, because I need the L. Oh, so it's just a little uname. It does some. Yeah. So it's just untarring something blindly from the internet, and then telling you how to set your path. But I've already got a nice. That was more for your benefit. Oh, thanks. Yeah, but boom, and that is latest Istio. So hey. Yeah, I assume this is nice because this means like automated tooling did it. That's cool. All right, so we got ourselves an Istio-ctl, and then because why not? Inside Istio, there's an install directory, and then there's a Kubernetes, and then there's Istio demo. .yaml. So we can cat all that. And do some wc-l. And then, so it's like 3,700 lines with some sourcing. So, it's fine. Boom. So you can see it's going to create just like a ton of stuff. Most of the way that Kubernetes, you saw a ton of custom resource definitions. Most of the way that Istio sort of does this is by extending the existing kube API. So while it brings a bunch of infrastructure for itself, it actually mostly uses like the etcd like for storage and stuff and those kinds of things. So there's a bunch of kind of cool stuff that comes out of that, but you're never really talking to the kube API. I think you're mostly talking to the Istio API, if my memory's serving me correctly, but it gets a little funky because it doesn't have its own data store. So I think it's almost like you talk to the Istio API and it does a little validation and then it sends that onto the kube API, but it's fine. It's fine. So we'll go through and we'll do like, a piss poor job of validating this. And like, don't be afraid of this command. Like, I know it's scary. There's clearly like a ton of stuff here. Oh, got like a little too much. That's annoying. Maybe if I drop it like just a hot sec. Is that not going to fix it? No. Okay. Close. Well, anyways, y'all can see what's going on. It doesn't really need age. It's just it's all this Istio pilot's fault anyway. But we're running a kind of a ton of stuff, so we can do the code. And we can give up on this. So there's a Grafana, an Istio Citadel, egress, ingress, pilot, policy, sidecar injector, StatsD, Prometheus bridge, telemetry, Prometheus itself, service graph, tracing, and Zipkin. So Zipkin and tracing are both for tracing. Service graph shows us, we'll see that in a little bit. It shows us kind of a cool like visualization of the services that are talking to each other. Citadel, I think, does the like MTLS. Grafana does what Grafana does, which is like visualizing. Visualizing like time series databases. It's like the standard how you show your metric system, you know, circa the last few years. I definitely have a meme with my friends where it's like Samuel L. Jackson in Pulp Fiction, and he's like, say what again? But I say like, show me Grafana again, do it. Because I'm just kind of tired of Grafana based demos, but it's also nice because it's like, oh man, I would love to know what's going on in my systems. Policy and Pilot do exactly what you expect. Pilot, again, is the thing that's doing all the like random configurations, not random, deterministic configuration of all of the envoys that are running around. Pilot is sort of your brain. The policy is where you kind of load and store policies for traffic mesh, stuff like that. Again, there's like a StatsD bridge. I think the sidecar injector is off unless you turn it on. We're going to do all our sidecar injection manually. All right, cool. So that with that stuff, you know, we're trying to kind of evaluate it. Like it's a lot of stuff, but it's not that bad. And in a microservices architecture, like this is kind of the plan, right? To build a bunch of little things, supposed to like bunch of stuff. Most of it's running. If you are running this, following along at home, the reason we don't have these are pending is because we don't actually have load balancers in the like super free tier on the IBM cloud. So if you had a paid cluster, we'd be able to bring these up, but we don't. So they're just going to sit here in pending for a while. And it's kind of a to-do for me to like maybe make like an IBM free tier customized that uses like a node port or something for these guys, but I don't know. I don't have time for that today. All right, so now we're going to kind of talk about this once again. This guestbook application. We're gonna deploy this sucker. It's a very simple application. Its only purpose is to kind of show that you can deploy an app. So we're not going to work too hard on the code itself, but we are going to try to have fun. All right. Okay. And so we're going to go into the V2, and we're just going to do some. There's a Redis server in this thing, and you can read the code if you want, but it basically just sets up Redis with a couple. We don't really like the word slave anymore, but that's a couple follower nodes, and that'll give us read access. I mean, it's a toy application, so we don't exactly need to read scale, but the whole point there is that you have the followers following the master, and they replicate all the data, and then in the app we have it rigged up so that it attempts to make read-only requests to the pool of followers first. Yeah, something you might do on a real application, but we don't really have to do this, but it doesn't really hurt anything, so no problem. Actually, we talked about how we're on the super free tier. By the time we deployed all this Istio stuff, all the default Kubernetes applications, and then a couple copies of this app, and then we're starting to hit some resource contention. So that's kind of fun too. It'd be cool to do something like jobs or something that are like known to be able to, ride the rapids of increasing and decreasing system load, and sort of chase those to see if we could, build a cool demo on that. All right, so we got this stuff. We've got a pod. All we've done at this point is deployed a database. We haven't deployed, I use the word database loosely. Redis isn't really for data, but it's not a bad use. All right, so typically what we would do at this point is we would run something like this, right? Which would take the guest book and deploy it. However, Oops. And we can look at that. There's nothing really crazy in there. I am going to change it slightly because there were some changes that landed last night. But yeah, all we're doing is basically saying, I mean, there's nothing spicy in here. We're applying a version. That's about it. And we're doing a little bit of resources, but basically just an app. So we would typically deploy this via something like that. But remember, we want this app to go in with an Istio sidecar. We want the Istio proxy to be running as a sidecar application. So how do we do that? Well, there's a couple ways. There's kind of an automated way and a manual way, and the automated way has some bug reports on it. So we're going to do it the manual way, both for instructional purposes and because it gives us a little more chance of trying to see what the heck is going on. We can kubectl apply to F, and then we'll use this sucker, which is like an old bashism for like take the output of the internal command between the parentheses and shove it in like it's a file or standard in or something. Istio ctl kube inject -f guestbook deployment.yaml. So enter command first, we're taking istio ctl, we're creating kube inject, and then we're digging at this, which basically means it's like a little handy helper the Istio folks wrote that processes this YAML and basically just adds injected sidecars to it. And then we'll take that and shove it into kubectl apply. So we can still kind of, as like DevOps people, keeping our configuration in Git, we can still keep it as guestbook.yaml and don't have to think about the Istio sidecars. And then the Istio sidecars code will get less attached at the last minute, almost like you minify JavaScript or something. And so this could be put in your actual deploy line. You know, I don't know the details, but you could probably convince Helm to do it for you. There's also nothing super wrong with taking the output of Istio kube inject and storing that as guestbook deployment.yaml. We can actually look at the output of that just for funsies, because it's only outputting text, and you can kind of see it's like all it's really doing is modifying the spec significantly so that it knows, you know, here's all the stuff we need. But then also there's a sidecar with a bunch of environment variables and so on and so forth. There's an init container, blah, blah, blah. Okay. Whoops. So let's go ahead and apply this. Kubectl apply -f istio ctl kube inject -f YAML demo gods. We come in here, we can get deploy. We can see we've actually got one. Kubectl get pod. We can see we've got this pod. We can kubectl describe pod. And what we see here, okay, first off, it actually happened. But then also, come up here, it says init container. Sorry, this is the deal with the init. And then in containers, we've actually got multiple sections. So guestbook and down here, Istio proxy. And sorry, I could show that for like a little bit longer. So here's the guestbook, which is like typically what you'd expect to see. You know, we pulled it from somewhere, blah, blah, blah. But then also we've got this Istio proxy down here, which did some stuff and has kind of a lot more to be said in terms of like arguments and so on and so forth. And you could tell that it's got this discovery situation where it's basically like, okay, find istiopilot.istiosystem, which is the interaction between kubedns and kube namespaces with this little dot. And then, all right, everybody, so you can kind of see how this is going to play out, right? Like every Envoy Istio proxy that starts up is going to use this address for service discovery, and then it'll know where its pilot is, and then pilot will give it consistent updates on how to change its configuration so that it all converges. Similarly, we've got some init container up here that's just doing some, I think pretty generic inits. I think this is the thing that's going to set up those IP tables rules. Pretty cool. And then, if you've never done this before, so that's describe, but logs is actually going to fail because you have to specify which container. The containers, like their names are just right up here, but they're really guessable, right? It's like C guestbook. And that's just basically saying we're listening on port 3000. That's just the logs of the app. And then Istio proxy is always named exactly what it is. Whatever, we're going nuts. And then I don't know if, oh, hey, that was kind of cool. So this thing actually has a whole environment variable set up. And then you can actually see the IP tables rules it's put in place, which is pretty slick. All right, so now that we've done that, we want to deploy the other app in this service. So we're going to do a kubectl apply-f, funky Pac-Man thing, Istio ctl kube inject-f, avatar deployment .yaml. That is what I meant. I just misspelled it. Thanks, though. Good job, IstioCutl. Although that's probably just some Go library they brought in. And then we will apply as normal avatar service .yaml and guestbook service.yaml. Looking good. Guestbook service.yaml is more useful because we actually do need a node port in order to one day actually be able to see this application. So with that in place, I think it's actually worth checking out and making sure that we've truly visited the app. So we can do a kubectl git service. So we can see our port is up here, and then node ports are kind of like the hacky way to do it if you don't have load balancers or ingress controllers, right? And what I mean by doing it, I mean actually seeing your application live as opposed to just running list commands and hoping that it exists. So there's kubectl. That's as far as we can get with kubectl. Now we have to go back to IBM Cloud. Cluster, CS cluster workers. herpderp. So that herpderp is my cluster name. And this is actually going to tell us things about the specific VMs or bare metals or whatever that are underlying this. In the IBM Cloud, by the way, you can have VMs that are shared, VMs that are dedicated, or bare metal hosts as workers in your Kubernetes cluster. And you can kind of mix and match a little bit too. You can also provision workers that have GPUs enabled. So you can do stuff with FFDL or kubeflow. Probably I should just come in here. We have a cool little logo, Fabric for Deep Learning. Anyway, so that means that if we hit this, which is constructed out of this public IP address, colon, this really high port number, we got a website, which means we can come in here and hopefully be able to visit our website. Hey! What's up, Twitch? And we'll set my name to Science. Hey! We'll set my name to No Name. Hey! So, generic guestbook application. And the only thing that's kind of microservice-y about it is that it's not very big, but also these avatars are being generated by a cool little microservice, and that's why we deploy that avatar thing. All right, sweet. So with that in place, and I'm not going to keep you guys for too much longer because we are getting a little low on time because I have to literally go to New York today. But let's see kind of what the deal is with let's like we're gonna play a little bit more with Istio's ability to instrument the system, and then we'll probably call it good. So git pod Istio system. So we can see we got all this stuff running, and no big deal. You can see that there's like some jobs that run, like, you know, when init containers is not enough, you need kube jobs. And we can kubectl git service Istio system. For those of you paying attention, you know the -n is namespace. So basically all the stuff Kubernetes needs to run is in the -n kube system namespace, and all the Istio core infrastructure I² stuff is in -n Istio system namespace. And you can see it's got a billion ports it's listing on for all these different microservices and stuff. So lots to be, you know, with more experience, one could really be a wizard with this kind of stuff, but I'm not quite there yet. And I'll cat this file just to show it to you. So these things are Istio specifics resources, rules, log entries, rules. There's some metrics up here somewhere. And these are essentially just populating out a bunch of stuff for Guestbook to actually meaningfully be instrumented. kubectl, Istio ctl create -f guestbook telemetry. I want to use Crete, like the small island. This guy's Crete's not that small in the Mediterranean Sea. All right, we created a bunch of stuff. So if we go back to this curl command, what you'll actually notice is all it's doing is like it's just like, I didn't write this, but this is how I write apps, where I'm just like, just load script.js and do it with jQuery. Fine. So in order to do that, we have to, yeah, heck yeah. So if you actually hit this curl, you actually get a JSON object back, which is an array. And you can see our data. We've got a message followed by a pipe, followed by a base64 encoded SVG file. And that SVG file is sort of where that image is coming from. So we can start hitting this in a circle, and it should generate some loaderinos while we, no. Okay. Sorry, Twitch. So I learned a new trick while actually doing this. So typically this is how I would do it, like while true, do sleep 1, sleep 0.5, semicolon, yeah. Oh my God. Done, right? So the while true and the sleep. There's this thing you can do where you take out all of this, where it's just while sleep 0.5, which returns true. I'm like, that's hacks. It's hacks is what that is. That's some legit hacks. All right, cool. So we got some load on the system, and then we'll come in here and we will do some, what we're gonna do is we're gonna do some like janky port forwarding to see that Grafana. So let's do a kubectl -n Istio system port forward, kubectl -n Istio system get pod shell app Grafana -o son path equals. Can he do it? Yes, he can. And then is this actually official? Is this the official JSON query spec? I don't know. All I know is that jQuery changed, or JQ changed my life. Boom. Oh man. I have to spell Grafana right. Okay, well let's try this little one in the middle and see what we can figure it out. Whoops. Okay, that returns nothing, which is fine. Oh, that was the problem, is that I didn't have items. It's all right, we good. Hey, that feels pretty good. All right, so now we're porting, doing port 3000 to the other side. We're going to ZBG that just for fun. And then we'll pop up here and we'll go to localhost 3000. My God. That was some memes right there. Have you ever Googled for localhost _ 3000? That's fun. Mike, do you want to hide the screen for a second?
Hold on a second.
What?
Yeah, give me a second.
Yeah, we have to go cruising around my home door. I didn't quite realize that, so I'm just gonna look at my pretty face for a hot second.
I'll show me for a second. All right, you're good.
All right, thanks. Sorry for the disembodied voice, everybody. My director has to.
I'll transfer you back in a second. Let me just hide the screen. All right, you're back. Just let me know when.
Oh, wait, that's not what I wanted. All right, you can turn it back on.
You're good.
All right, so basically all we did was we did this import and then we went cruising around for a file, which is fine. Which is just on JSON, it's just on GitHub. And we import it and then we get this thing. Hey! And so there's a bunch of cool stuff I want to really highlight here. All right, so the first is there's this thing called RED. If you're kind of new to metrics and monitoring, RED is a great use in RED, right? But RED is the first one, rate, errors, and it's just an acronym that stands for rate, errors, and duration. And that's exactly kind of what this graph does. It gives us a general sense of what's our rate? How much request volume are we actually doing? Over here, we've got an errors, success rate by service, 500 responses. And we can look at the difference between 400s and 500s. For those of you following along at home, 400s are kind of like the server telling the user that it's done something improper, like no, 404 not found, 401 unauthorized, right? And then 500 are usually some form of internal server error. Like you made a request that I didn't kick out in my validation step. I then tried to execute and I crashed. So a lot of times you'll get 500s from an Apache when PHP behind it crashed or something. Then down here, we've got some durations, which gives us the P50, the P90, and the P99 latency for the different apps we have. As you can tell, we've got Avatar and Guestbook, and then a couple just random Istio systems, things in the Istio infrastructure that are instrumented as well, just for funsies. What you can see though is that we're actually getting 0 requests per second on our Avatar, right? And the reason we're getting 0 requests per second on the Avatar is look at this request. This is a GET request. All it's doing is what's in the database, what's in the database, what's in the database. And we're actually caching the responses of that Avatar microservice in our database. So the only way we're going to hit the get activity on the Avatar microservice is by doing some kind of a write request or something. And there's another way we're going to use Istio to kind of show that. I think before we do that. So let's go back to this thing. And we're going to just do the same port forwarding we've always done. And we're going to show something called the service graph, which is more or less what it sounds like. I'm going to remember to pluralize item because I'm good at it now. And this that's not your fault, everybody. That's my fault. Sorry, everyone. All right, let's try it now. Boom. All right, yeah, it's always good when like last night's demo is still running and you have port collisions. Good stuff, team. All right. Okay, so now that we forwarded that to the service graph, remember when we kubectl get-n istio system service? Oh my god, what just happened? All right. We have all these services running, so we just started talking to Grafana, and that's what this is, with a nice little red graph. And then we have also got service graph running here, which is another cool little thing, and that's on 8088 like an 808 drum. So now that we forwarded that, we can actually come in here and we can do this. And we can see one of these guys. And if you're like me, you know, you did this with Puppet for a long time, you can see a graph of how things are talking to other things. Unknown to guestbook, guestbook to avatar, avatar talks to the various Istio systems, you know, like, oh, hey, am I allowed to talk to that person, blah, blah, blah. What you see here is really low throughput, and we can actually do some cool filtering with filter empty equals true. See, some of these are 0 requests per second. True. You can see an example of just recent requests, of just things with requests, and we can set a time horizon equals like say 30 seconds. Or we can go back maybe and say 300 seconds, and the avatar should come back. All right, the avatar's not coming back. That's fine. But since the since the avatar isn't coming back, we can actually go ahead and do kind of what we're talking about, where we were gonna make a write request into the database. So it turns out this is not that hard. All you have to do is modify it a little bit. So there's like 2 query parameters, not even query parameters. They're like literally just, it's on a quote. So you say like something like, my name is Spencer, and my message is cool website. Oh my God, I'm not going to put that quote in there. And I'm going to put quotes everywhere because I'm scared. Oh. The only thing you have to do is come back here. And if you're familiar with Redis at all, these rpush and L ranges are very, yeah, cool website, cool website, cool website, cool website, cool website. And you'll see that every time we run that, it actually gets bigger. It's longer. So now that we're adding value to it every time, we can come in here on the 30 seconds, and we'll see that the avatar is starting to get, you know, requests per second. The RPS is going way, way up. Because every time we send a request to Guestbook 2.0 that's a write request, it has to go to avatar with the name, turn that name into an avatar, get the SVG code, and then return it. You can actually see the direction of the request here, which is cool. There's another, there's like a, you know, if this dot visualization is like hurting your brain and you're like, hey, it's not 1997 anymore. Like we've got the fancy JavaScripty one too. Hey, and then you can click and you can see, you know, incoming and outgoing connections. Guestbook's kind of cool because it has incoming connections and outgoing connections, which is pretty slick. You might be asking, why are there so many more incoming requests than outgoing requests? Shouldn't those be unified? And the answer is they are. But the nature of the Guestbook app is it actually is just constantly polling like once a second or something like that. How do I access localhost? And now that we've got those, we can actually see some stuff coming up here. We can see we got a 400 for some reason. Guestbook gave a 400. So, oh, you know why that 400 was like literally me screwing with it and like sending to oh, that's fun. All right, yeah, let's do it. Okay, so now, okay, stop. And then give me this. Do that, and then VG, G. And give me one of these curl, like random path. Never leave spaces. All right, so that's giving me a 404. So we can come up here and we can say while true do sleep to do done. So every 0.5 seconds we're making a good request, and every 2 seconds we're making a bad request. So we can come in here in our graph and we'll actually see, you know, how many 400s and things we're actually starting to get. So seeing a certain percentage of 400 requests. Yeah, and we're getting errors. I don't know why Guestbook 0 is at 0 ops. Because so 200s should be getting some 200s. I think my for loop stopped working, which is okay. Yeah, because I probably like BG'd on a sleep or something. So we'll just do 2 terminals. It's no problem. That's going to keep going. All right, let's make this even more complicated. Let's have it write new data in like every 4 seconds. And let's have it 404 every 2 seconds. And let's have it read every half second. So there's the read. So there's the error, and here's the write. And so now our Grafana dashboard is starting to look all kinds of cool. We have total, you know, here you can see the orange is like all requests, unsecured request space. And then the yellow, which used to be exactly what the orange, is starting to change because the number of requests is different. We're starting to see a few 400s. I don't know why this is zeros. I don't know. I guess I've got pretty intense sleeps in there. Anyways, you can see how your app becomes sort of visible Play with Grafana a little bit. So we can see, like, yes, we have a pretty standard number of 400s, although I guess we're off the refresh cycle, so we're seeing a little bit of a sawtooth. This is where I canceled both. And now we're seeing a lot of 200s. Like, we're getting a lot of very positive requests, because those are all those read requests. And we're seeing some 400s from time to time. And then somewhere, I think that might be on a different dashboard that I don't have time to show you, but there's a way to look at like the size of the requests. And since we keep pushing more data into the database, we're actually seeing more and more every time. Cool. All right, so that's sort of this guy. I don't understand why these are zeros. I guess maybe because there's actually 0 operations per second, because we're just not operating fast enough. This is 0.4. Oh, did this crash? It looks like it's working. Huh. Oh, anyways. All right, everybody. So that was kind of what I wanted to show today, just to resuscitate. So this is the guestbook application that we put in there, guestbook dash. A lot of the tutorial I was following is found at github.com/ibm/istio101. And in this workshop area. And then what we're talking about mostly today was this Istio software, right? So the purpose of that software, again, is to build kind of a service mesh with a lot more instrumentation and control. So hopefully on a follow-up cast or something, we'll do something cute where like we play with the traffic control opportunities of Istio. You know, we had sort of brushed over the idea that you can do this request routing, 99% over here, 1% over here. And you can do that based on the version of service B or whatever. Gives you a lot of control and opportunities. Blue-green deploys and all that kind of stuff. With that in place, the last thing I kind of want to pump, you know, as always, is the, IBM code patterns. You know, we've got a ton of these that are quite ready. You know, just come over here to developer.ibm.com/code, go to the patterns, and then whatever you're into, you know, we've done a lot with container orchestration containers, but there's messaging, Java, IoT, API management, whatever you're into, let us know. I also want to talk about callforcode.org, which is an opportunity for developers anywhere to participate in a global hackathon for innovation and good. We're partnered with the UN. There's $200,000 on the line. And your code would be immortalized in the Linux Foundation as open source software. And then the last thing really is this Istio Day. You know, if you're available in Portland and you want to come to this thing, it's July 17th. It's Tuesday. It's going to be all day. Come for half day. Come for the full day. And learn everything there is to know about Istio. We got, you know, ballers like Kelsey Hightower in place. We got plenty of people from IBM, plenty of people from not IBM. Lesh is going to be there. CA Technologies is buying us food trucks. It's going to be good stuff. It says you need an OSCON pass. I think that's not like super real. Like if that's true, you know, just hit me on Twitter or something and I can probably get you in, like no problem. And so, yeah, that's what I had for you today. This has been Istio on the IBM Cloud. And thanks so much.